Okay. Good morning, everybody, and good day to everybody all over the world that are joining us. So it's great to be here once again. So I'm really grateful for those who came in early and those who are just coming in now. I'm really grateful for your presence here. We really appreciate it. Okay. So I'm quickly going to go through the agenda for today. So today we're going to be looking at a practical view of R in epidemiology. Okay. So we're starting late. Actually, we've used a few first minutes to admit our participants. So I'm going to go through the agenda now. So we're glad you are all here. Then the next thing will be I'll introduce our speaker. Then we'll allow her to talk on the main thing for today. That is the practical view of R in epidemiology. So then we'll take Q&A after the webinar, after our talk. Then we'll give the vote of thanks. So I'm going to briefly go off the screen to give the view to our speaker. Okay, so today we're having Elena Dudukina. I hope I got that right. Okay, good.
Correct. Thanks.
Okay, so she's a PhD student at Department of Clinical Epidemiology, Aarhus University. I hope I tried. Okay, she is really into conducting research in reproductive health, focusing on abortive or near abortive events in pregnancy and their effects on the long-term health of the children and women. She is interested in pharmacoepidemiology, especially drug utilization and safety in pregnancy. She is also very passionate about causal inference and R stats. So join me to welcome Elena. So I'm going to hand over this session to you. So thank you so much for joining us, and we really appreciate your audience here, your presence, your time, everything. We're grateful. Thank you so much. So you can go ahead now.
Vicky, I also wanted to say thank you for finding the time to join today. It's Saturday. I can imagine you also have other plans going on, and also thanks a lot for Our Lady Abuja for inviting me to speak with you. I will share my screen and give a short introduction about the topic that we are going to use today for illustration purposes. So, as Brigitte mentioned, one of my interests is drug use in populations, and I work in Denmark at Aarhus University, and Denmark is very famous for having really high quality data on medicine use and on many other aspects of medical system utilization. And this kind of questions are actually really popular in real research. What kind of drugs are used in specific groups of interest? What does it mean? What patterns can be explained by what factors and so on? So this is an example of a paper that investigated the switching between different antibiotic type among Danish children 0 to 4 years of age. And you can see that this is a whole published paper that investigated the patterns of antibiotic prescription in these children. And today we will be doing something that I think is practical. We will not be using the same data as was used for this particular research, but we will be using some aggregated data that is freely available for researchers to use. I will stop sharing this screen, and I will share the screen where I will introduce the data that we're using today as an example for drug utilization research. So this is the Danish website that is dedicated to show transparently the drug utilization in Danish population. And you can see that it has a lot of different things going on. First of all, you can choose the group of medicine that you're interested in. You can choose the year or all of the years to see the trends that are going on. You can also choose the entire country or specific regions. You can also choose the sex or both sexes combined. And also you can have quite a lot of variety in terms of what age groups are entering some information that you're interested in knowing. Before, for example, forming your research question, that could be a great tool to know what is going on in any particular medication use area. So as an example of what kind of an output this system can produce, I will show this screen. So on here you can see that we have the years, and this is utilization of antibiotics altogether. It is the group J01. We can see the prescription and the drug utilization for males and females and for genders combined throughout the years. And this is very interesting and valuable statistic to know, but sometimes it might be really hard for people to perceive this information and see patterns in the shape of the table. So it might be okay for a report, but it might be okay for a presentation. And even for a report, you sometimes want to have this information aggregated in a better shape or form. And sometimes you want to have, let's say, a different age group sizing. So you don't want this group to be in the bands of 0 to 17 years of age, but you want it to be from 0 to 18, or you maybe want to have some other grouping by age. And that is the case where you can use R to help yourself by extracting the data that is openly accessible and preparing something for yourself or your colleagues to work with. And now we will get to the interesting part, that is using R to use this data to develop the question and answer the question that we have. So today I want to know what was the utilization of antibiotics and specific classes of antibiotics in Danish population from 1999 to 2020, and in the latest available year. And I also want to know the drug utilization by specific age groups and by sex. I want to produce some nice figures using R, and I also want to produce a summary table that will show me the drug utilization in specific age groups that I think are vulnerable or are the groups of my focus or specific interest for the recent years. And to do that, we will use R throughout. I will now share my R screen. Please also feel free to ask things while I'm speaking. I think that would be easy for us to go this way because we're not a very large group. So if there is something you want to ask, just go ahead. I think raise your hand and we can just discuss it. So I pre-ran some piece of code because it takes a while, and you can see that my memory is quite occupied on this machine. So what I've done before we joined is that I loaded some packages that I'm going to be using, and I use a lot of packages from titles to aggregate and reshape my data. I use my Gridder package for the nice pipes that allow me to move data from one code line to the other code line. So it goes just like a pipe very nicely. And I will also use the library by Sanderson for some color schemes for the graph. So you can see I've already run it. And these are the links for the data that I'm going to download from the Danish system with aggregated data that is openly available for researchers. So the things that I'm downloading are the medication use per year. You can see from 96 to 2020, and the labels for the drugs, because it's not always that you know the codes of all the classes for all ITC codes. And even if you do, it's always nice to have some label on your figures or in your tables. We'll also download the data for the drug use itself, and I will download the data on the population per year.
Excuse me.
So
Okay, sorry, I actually was raising my hands there. Sorry, could you help us to zoom a little bit so that we can see clearly the script you're working with?
Okay.
Yeah. Okay.
Let's see.
Thank you.
Let's try 110 and ability. So let me know if I didn't see your hand raised because I'm not a host, so I cannot see that. Only you can. So you just go ahead and tell me if this is okay.
Kindly respond. Okay. I think it's a little bit okay.
Is it better?
Somebody's saying maybe more.
Yeah, maybe more.
Okay. Okay. Let us see. Okay, the next option is 125%. Is this something that is better now?
Are we good with this? Okay, okay,
Let's
yeah,
see.
it's
Yes.
okay. It's okay.
Okay,
it's
great.
Okay.
Okay, let's continue then. Right, so this is the code with the links that I'm going to extract. And before we started, I ran this code, and this code, because it takes quite some time to upload the files. So what is happening is that this read the lim command from reader package reads the files in each of the links that are provided here. And then it outputs, it saves each column under V and number name. And then I bind all the rows because each table now is the year, and I want to have all the years in one data table. So data frame, we can just run and see how it looks like. So you can see there is a variable, there is a year, and there are ADC codes. So this is nice. I also want to have some other information before I can do something, and we will just upload it now. So let's upload the drug name that we have, and I will use exactly the same code as the previous one. So it will take the line here that I named EDC groups.txt, and it will upload the data using this link here. And then I will filter only the variables that I need, and I already will rename some of them while selecting by using the select command, because I don't need all of them, but some of them are going to be useful for us, such as ATC code and the name of the drug. And I will just read that, and we can see how the data looks like. So as you can see, it is the same ADC code as we have here in our main data frame that I've uploaded or downloaded one step earlier. And we also have the name of the drug. So we are interested in antibiotics, and it is the code J, and I'm pretty sure it's somewhere here. I mean, we could have just looked at the table, but I can maybe just go like that, a bit of a savage approach to show you that it is there. Maybe not, but it is still there because these are all ADC codes that are in the data that we're using. Okay, and the next step that I'm going to need is the data on the structure of the population, because my ultimate aim is to compute the incidence rates of drug utilization in specific groups. And in order to compute incidence rates, I need first the number of users of the drug that I will take from this first table that I've downloaded. but I also need the denominator for the race, and denominator is going to be the size of the particular population of certain sex and certain age. And that data is stored in the population data, and I have also some code that I prepared. So let's see what the population data has for us. So the population data in this piece of code before, this is how I named the link, and this is the link itself that we are going to use. And this code does exactly the same as we did previously. This function calls the link that has this name from the previous list that I created. It knows that delimiter between the columns is semicolon, and then I just name again all the variables with D. I know that there's going to be 7 variables, so this is Y, and then all of them are going to be characters. I also going to select and at the same time rename the variables. I know that the first variable is the year, and I know that the second variable is for the region, which is going to be saved as text, and also the region that is a code, so a number. I also know that the fourth variable is gender, and the fifth one is age. And the most important one is the denominator per year that I'm going to use for calculation of my incidence rates of drug utilization is this variable number 6. So I will run this code and we will see how the population data looks like. So this is how it looks like. I have the year, I have the region that is DK for the whole country, and this is the numeric code, which is 0. I also have the gender that is coded, either 1 or 2, that I need to address later. And also I have age that is saved in this format, and I also need to address it. The denominator per year is the size of the population. So in 1996, the whole population of Denmark that was aged between 0 and less than 1 year of age was of that size. So this is what we have, and now I need to do some additional things to, first of all, for example, I want to have the label for the gender, and for that I need to do something. So we will use our bulk data, and I will mutate it. And I'm horrible online typer, so sorry for that. And I also, since I have this code prepared and I don't want to spend too much time typing, I will just copy paste it. And this is what we will see. So I will create the variable that is called gender text. I will use to do it using the variable gender that we already have. And I know that one is for men and 2 is for women. So this is what I'm going to do. And also I want now to address as you can see that the format of some variables that are actually numeric are stored here as characters. And most important of them is age, that I want to be numeric because this is how our minds work when we think about age as a number, not as a string or as a character. And I also want to address that. And this is what we're going to do. So I'm also going to mutate this data further. I'm going to mutate all variables that I mentioned now under a function vars here. It will be year, age, and I also want to change the denominator per year because when we uploaded the file, I chose at first that this variable is going to be a character, but I see now that I want it to be in numeric. So I will do it now, and then I also want to arrange my data such a way that this will be kept as is, then it will be sorted by age, then by region, and then by gender. So I will do that, and then I can check. Oh, that's interesting. That doesn't apply. It doesn't do something. Try again.
Okay.
Yes.
Okay, let me, okay, I think line 76. Okay.
76 is that.
Okay, okay, you've taken it. Okay. I think the problem was the pipe. I think you're good. Okay.
Okay, let's try again. Am I missing the pipe? It's really weird. It happens all the time when you're online coding. Something just doesn't work. Okay. Selecting, mutating. Maybe I'm just really missing something. I will do the copy paste because I want to spend too much time now on that. Okay, probably there was some pipe mistake. I mean, it's exactly the same code. So we had our population data, and now I just want to check that this is indeed what I wanted, and it is what I wanted, because you can see that now I have the gender text that labels my gender, and the age is now in double format. So it is numeric. And this is exactly what I wanted to have for this data to use it nicely later on. So now we have a problem with our main data, because first of all, we haven't seen how it looks like fully, but let's have a look. I will slide first, let's say 1,000 rows, and I will output it in the viewer. And this is what we have. It's quite raw now, so you can see that the variables names are not defined in the way that I want them, and I need to do something about it. But the good thing is that I know which variable is what from the description of the documentation of this data set. So it's not going to be too hard for me to address these things. So first of all, I want to rename the columns that they make sense to me, because I know that the first variable is the ATC code and so on. And I will run that, and that will make our life better already. It's a bit slow, but let's see. Yeah, because the data is quite big. If you look at the number of rows, it's in the millions. So this is why it takes a bit. But let's hope that my program can digest it. I mean, I totally know that it does. While it does that, and before it finally outputs what we have there, I will continue to address some other things. What I think are important, first of all, we need some nice labels for the renamed variables that we just did. For example, for the regions that we only now have is the, okay, I will stop this because I think that it's not running well. So I will have some region labels, and I will also label our gender, although for this part, I will only use the certification by sex. I don't want to use information for both sexes. And this is where I will address the issue of having too much data. I will only keep the data that I want. I will filter the entirety of the country. I will select the sector for which we have most of the data, and that is the prescriptions from the local pharmacies. And I also don't want to have both sexes. So we will run this part. And then there is a piece that we still need to do something about. And that is how gender is stored, or how age is stored. Yeah, okay. Since I normally don't use the computer for my computations, and this is why, because it just cannot digest all of the things. But that's fine. We have a plan B for such situation. it cannot locate the vector. Yeah, this is totally the problem with the memory availability. But that is fine again, because I have the file that is already worked with all of these things. So I will just continue to progress logically what other things I would have changed in the data. Sorry, we've already done that. I need to deal with non-numeric age, and I will just again have a look at this raw data to show you. So as you can see, we renamed the variables nicely, so that's great. But the age, first of all, it has different coding for what kind of groups we are using. So it's totally not the number. And then at some point, it is not going to be a numeric as well. So we need to address first the part of what ages we want. And second of all, we need to make it numeric. So as you can see that this is a specific thing for this data. So age just means a particular age category. And I don't want to have that in this data. So I would love to address that. And unfortunately, I know now that this machine will not run it. So what I would do with this data next on is to only keep the data with the numeric age groups. And then I would make the age numeric by using the parse number function. And then I will select only the variables that I need. And that would already shorten our data to the size that is digestible to a more modest machines with not a huge memory available, such as this computer I have, my work computer. So, and then we would have the final data to work with. So normally I would run it and we would have the data, but since this machine cannot do that, I have to upload the final data that I saved after working with that. So before I do that, another step that I would do before having the final data that we're going to work with is that I would save the ADC code that I'm going to use to analyze today. So the antibiotics altogether is the J01 code, and then each of the subclasses, and that would create those regular expressions that I here pronounce regex. So each of these objects in my environment would store a specific subclass of antibiotics that I want to keep in my final data. And to make my life easier, I would create a string of all of those regular expressions that would be separated by this thing. So this I can run. And I would use this code to filter my data. And this is the code that I would be using for that. So after running all the previous pieces, I would only keep the ADC code that's defined in this string that combines each of these. So each of these codes, and this regular expression that says that my code needs to start with K, then it needs to have the number that I want, and then it needs to stop. And this has something to do with how those ADC codes are stored in the data. So if there would be nothing here, then I would collect all of these codes as well in this code, but I don't need that because I know that the number of users was already computed for antibiotics altogether under this line in the database. So, and after running this step, I would actually have a very nice and not so large data set to have. So I will upload it now because I have it saved. So let's do that. And what call it? Call it here my file, and it's going to be the path. And unfortunately, in Windows, this is not how the paths are working. So I have to do this to make all backward slashes, forward slashes. And then I need the file itself. That is called like that. And then let's see how it goes. So this is our file. Oops. Let's see if it looks how it should look. So this is exactly the file that I would have gotten, and my machine could run all the previous code on this huge data that in the end it couldn't digest. So you can see it's still kind of a largish file, but it's only 33,000 lines instead of, if you remember, millions of lines before. So now I have the year, and you can see that the data for antibiotics only starts from 1999 instead of 1996, where all of the data starts for some of the other medications. You can see that I have the gender is the double, the age was parsed this number using the code before, the same for the number of users of the drug, and then also the incidence rate. So now we can see how the data looks like using, or actually before looking how the data looks like, what I want to do is to join this data with my population data, because if you remember, this is the incidence rate that is computed for the age 0, for the age 1, for the age 2 years, 3 years, and so on. And I actually want to have a wider age group defined in the way that I want. And in order to do that, I would have to recompute the incidence rate for the ages that I've defined. And for that, I would need the population data that we extracted and worked with earlier. So now I want to join this data that I have with the population data to remind you how it looks like before. So what I needed to do is to collect the information on the denominator, that is the size of the population that I'm going to make later on. So I'm going to do that. As you can see, it gives me error. Is it because it already has it? That's a good question. Let's have a look. Maybe I already joined it before I saved it. No, I actually don't think that. Oh yeah, because the gender is of incompatible types. Great. So what about gender? It's double in here, and it's character here in the population. So fine, we can fix that easily. Probably we didn't do that before, but that's weird, but that's fine. Let me do that here. The code that I will share runs completely normally fully. So something that happens now is just because we cannot run the whole code. So the gender I want to have numeric. And then it should be fine. So now let's see. Yes, this is what I needed. I needed the denominator here for each of the groups that we have here. So that is great. That is exactly what we need to do to later do something. So as I said, I don't want to have the medication used by such a fine strata using just ages in the bands of 1 year. I want to have a larger categories, and this is how I'm going to define them. I want to have a large category of children until they are 19 years of age. So my cutoff is going to be 18. And then I want to have a category that is people older than 70 on the other side of this distribution, and everything is between is basically cut in 5 years. So you could have done this part smarter, but for illustration purposes, this is also working nicely. So I will run this part and let's see how our age groups are looking now. We will count our new variable, that is age categories, and we will run it, and this is what we have. So all of the ages from minus infinity in our case, starting from 0 to 18, there are more than 6,000 of them. As you can see, 18 is inclusive here, but not inclusive on this side, on the left-hand side in the next category, because it was the cutoff, and so on for all the other cutoffs. And I have a pretty numerous category of elderly who are more than 70 years of age. So again, that's great. This is what we wanted to have with this data. So let us have some kind of a look of how this data looks like. So first of all, just to have some kind of a crude idea of what is going on, I will just plot it and to not spend too much time on copy pasting, I will have this tiny code snippet for ggplot. So I will get our data, and then I will only keep the ADP code that is for the regular expression of all antibiotics. So this code here, and then I want to have a trend of the patients, users of the drugs per 1,000 inhabitants that we have, and I also wanted to be distinguished by the gender using color. And then this is just some kind of the customization that is not very crucial, but sometimes it's nice to have a graph that tells you all the information. So you can see we have a lot of dots, right? And this is not what we want, because we want to have one dot per one age category. And this is still in our data, there is one dot per each age category in the band of 1 year. So we still need to work to get this data to our final data that is going to give us some final answer. So in order to do that, what I need to do is to compute or recompute the antibiotic use. So this variable here, patients per 1,000 inhabitants, using the newly created age categories that I've done. And I have a code snippet for that. So first of all, I need to remember that I want to have the drug utilization by gender, by each of the new age categories that I've created. And I want to have that for all antibiotics prescribed, so this ADC variable, and also for each of the subclasses. So basically, I want to have information for all of the things that I've defined here. So that's why I group by all of these factors, because these are, and also by year, because these are the mini groups within each. I want to recompute this variable that is patients per 1,000 inhabitants. So my numerator is going to be the number of people, so the number of users of each of these drugs that we have in our data. So I have this number, and that is great. Then I need to recompute this numerator per the category. So if you can see in this category, there are a lot of lines. So I need to sum up by gender and by ADT code and by year, the number of users, which I'm going to do here. And then I need to compute the denominator for my incidence rates in the same way. And that is to sum this number, so the size of your population, again, by gender, by ADT code, and by year. So this is what we are going here. And after I've done that, I will only keep one record per each gender, per each age category, per each ADT code that I want, and per each year. And then I don't need the variable age anymore, because instead of having many, many lines for each category, I will just have one line for each category after recomputing the incidence rates in the way how I would define the categories. So this is that I have, and you can see that now my data is my final data. It's much smaller. It's fully aggregated in the way that I wanted. So you can see this is my numerator when it was summed up. You can notice how much bigger it is. This is my denominator, which was summed up by year, the ADC code by gender, and by year, right? I've already mentioned here. So exactly by all the factors that I want to have this number. And as you can see, there is now one line per year, per code, per gender, and per age group that I redefined. So this is something that now will bring us closer to answering this question that we have. So I will use the previous code that we had before for this data. So I will again only keep the ADC codes for the antibiotics altogether, the whole group. I will plot it as a trend on the x-axis, and I will have the rate of utilization on the y-axis. I want now color to signify each of the gender categories that we have, and I will have two different sub-figures for each of the genders. And then I will use some customization so it looks a bit more nice. And this is what we get. So you can see now each dot corresponds to each age category that we have redefined. And I have a separate subfigure for the men and the women, for girls and the boys in the age category under 19 years of age. And this is how the trend lines are looking. I mean, these are now dots, so we can actually make them also lines to understand how the utilization is different and how it goes by gender as well. So let's do that. I mean, it will not take us much time because most of the code will stay the same. I will only change the geom. Instead of point, it's going to be line. So let's see how it goes. I also maybe want to change some things in my code snippet. So again, this is gonna be the plot only for antibiotics altogether. This is this line that defines that we only filter or keep in the regular expression for this code. Then I also want to create a label. So I want to know the age categories, not as here, because this is a huge legend and it's really hard to color match each of the age categories to this legend. Instead, I want to have each of the age categories mapped with the label on the plot itself to help me understand what is going on for each age category. And the label for that will be, first of all, I need to find one dot that is going to be labeled. And in this case, I want it to be labeled at the end of the data availability. So in 2020, that's why I want to create this label variable that will take the value of the age category at the time point where the year is maximal, so 2020. For everything else, it will be an A character, and the A character will not be mapped on the plot. Everything else stays the same as it was on the geom point plot. Instead, I change here to geom path to have a nice line chart instead. And then I also do a little change here. I want to have my scale labeled on the right side instead of the left side. And this last line is going to perform the labeling itself for me. It will show the age category at the right-hand side of each age group. So, as you can see, it told me that it ignored the rows that contain missing label, and this is what I wanted exactly, because what I want to have is this. I want to have each utilization rate trend over time labeled. So now I can see that the upper line and the highest utilization of antibiotics, antimicrobials for systemic use overall is the highest. For the older age category, older than 70 years of age for both men and women. And I also can see how different the utilization rate over time for boys and girls in the age category less than 19 years of age. So from 0 to 18 inclusive, it is much higher here for the girls, and then it declines for both boys and girls, but utilization seems to be staying higher among girls anyway. And all the other age groups are located much lower on both plots, but again, overall utilization in every age group in women seems to be much higher than that in men. So this is what we wanted to see. And now it's also clearly nicely labeled for me to interpret, and I don't need to color check with the legend every time. So now let's imagine I want to have such a plot for all of the age groups that I've created, but I don't want to copy paste my code every time because that would be time consuming. And honestly, I don't like that, because then if you need to change something upstream in this code, you need to change it in every code. And I mean, great when you have Control F function and this is something small and simple to change, but still it is error prone. What I like to do is to use this function that I've created already for myself to have this nice plot, and to use it for all the other ADC codes for each specific antibiotic podclasses that I want to know more about for this population. And so in order to do that, I will take this code and make it a function. So, and how I'm going to do that is that I will take this thing here, I will copy paste it, and then I need to create my function. I will call my function plot use. Yes, there is a question. I think I hear someone cheating. Okay, maybe not. So, and then I will create arguments for this function that I'm going to have. So I will have my data, and then I will have my drug regular expressions for each of them. And then I also want to change the title of each plot that I'm using. And this is going to be my function that I'm going to copy paste my function, and my data becomes an argument here. Now I have this regular expression that I use here, and I want to have a list of these that I'm going to use later on. So I use something that is called operator curly curly for making this, to force this function to evaluate this whole part in a tidy manner. So instead of copy pasting, I just wanna have a list of values of regular expressions that I will throw into this function, and it will repeat the code, this piece of code, for all of the values that I'm going to supply here. So this is the part that I'm going to do. Also, I want to change the title, because this is the title that I have now. And instead of having antimicrobials for systemic use, I want to have what I will provide in the specific list of values later on. So I would create a string by using this title character that I will supply, and keeping the rest the same. So my new title is going to be created by using the space function, and then it will paste whatever I put in this title in this function here, and then it will paste this text, and the rest will stay the same. So this is great. This is what I need. The data will always stay the same. So this is fun. Now I run my function. It's called cool. So it should work. Now I need to prepare the list that I'm going to provide into this function, which I'm going to run. And first of them is the list of regular expressions. And I have the snippet prepared. So I want to run, as I said, write the same code for all the subclasses of the drugs. And I will use those regular expressions that I've done before. If you see, each of them contains the regular expression for each of the drugs. So this is going to be my list of regular expressions that is going to then go in this argument in my created function. Then I also need to create the list of the titles. And basically it's the same as the list of regular expressions. It's just that for each place here, I will write nice text that will take its place here in my function. So I will run that. And then I also want to have the nice list of plots themselves. So, and for this, I'm going to use nice. So this is going to be my output. The list plot is going to be the list where each element is going to be the plot for each of the subclass of antibiotics I want to know something about. So, and then I'm going to use the per function map2 that takes two lists and puts them into positions of the function that I'm going to run. So the first list that I'm going to use is my list of regular expressions. And the second one is the list of titles for my plot. Then I'm going to use my own function that I just created. That is the plot used. And then the data is always the same. The data is, as you can see, my argument ADC data is my ADC data that was created and used for making the plot before. And then for the drug irregular expression argument, I'm going to take this list of regular expressions and I will reference it as X. And then I will take the argument for the title and I will reference the second list of expressions that I have here, and it will be Y. And then I will run. And it did exactly the same as it did for the previous plot. It just removed and ignored something that maybe the function doesn't contain anymore. I don't know, but it's a warning. Let's see how it works. So I have my list of plots. And let's see what we have there. I know that it should be 10 elements because these are 10 classes. Okay, 8. Is it 8? I guess it is. It knows better. So let's have a look at the first element. See, just magic. I have tetracyclines in my title. I know that this is tetracyclines because this is how the data was filtered inside of the function. And I have exactly the same figure as I did before for antibiotics overall, just for this class. And then I can do that for other classes, or I can just output it all together. So for example, I just want the first 5 and I can do it like that. It will show me all the warnings about removing the NAs in the labels, but this is exactly what I wanted. So while preparing the report, for example, in session R markdown file, I can just reference each plot separately within the text by using this code. For instance, as you can see, by doing that, I created those plots. And as you can see for amphenicol, the data is really scarce. It's almost not being used at all. The last use was reported somewhere in women back in 1999, maybe 2000, but that's it. Here you can see that beta-lactams and penicillins are being used mostly. And again, the distribution is similar to antibiotics overall, because of course this group defines the statistics for antibiotics overall. And again, it means that despite overall decline in antibiotic use for both sexes, women are being prescribed antibiotics at a higher rate. So then I can also go to other beta-lactams. That is a different plot, and another one for sulfonamide and trimethoprim. And again, we see how different the patterns of prescription of this particular class of antibiotics by gender. So I can use just one line of code to produce 8 plots, each of which is specific to each class of antibiotics that I have. So this is really useful for me, and I don't need to do something extra. I don't need to copy paste my code. If I need to change the styling, if I need to change anything here, if I need to change the breaks, if I want to change the color palette, for example, if you want to use the color palette of the organization that you work in, it's really easy. You just need to change it inside of this function instead of copy pasting this color palette in each of the plots. And to finish the presentation, if you remember, I wanted to produce some nice table with a summary of the drug use for specific age group. And this is the snippet that we could use. So it filters the data in a certain way, which is nice. So I only want to have information for the potentially vulnerable groups that are children and adolescents, and then for the elder people. But maybe that is not the nicest shape to output such a table. And I also don't want to have all of this data like that. I don't like how the things are looking. They're looking like a machine reading data table. And I want this to be a table that gives a vibe that it is for people to look at. So maybe I want to change something. And so first of all, I want to round the numbers for the medication use. So it's a nice and short number. And I also want to select only certain variables, and I want to rename them nicely. So what I want to do first is, I said, I want to round my numbers of utilization so that the number is not looking like that, because you can see that the precision is such that it doesn't really make much sense. I also only want to have the data for the last 2 years, because I think I did not mention that. So this is why this part is here. And I want to select only certain variables while renaming them. So instead of having this gender underscore text, I just want to have gender. So we can do it like that. Oh, something didn't work, great. The drug doesn't exist. What does exist? Let's see. Maybe I renamed it somehow or did not. Oh, that's because I did not show him with the drug data. This is great. So now I actually want to join my data with the drug data that I did before. I want to do the left join. What did I call it? It was the OMG drug. Yes. Now let's just check that it did what it needed. Yes, this is what I wanted. I wanted to have the label for each of the ADC code so that I don't need manually check it somewhere else. And this is great because I have data for that. So now it should work. Yeah, that's great. Now I have the gender and it looks already much better, like it's meant to be read by people. It has year, it has ADC code, it has the drug itself, and also it has the use per 1,000 capita. That's great. So I could have left it this way, but I also want to do something extra, and that is I want this data to be nicely comparable between genders and by age. So I want to make it slightly in a wider format. What I want to have is to have men and women in each age category in the column here, while each number inside would be the use per capita. So then it would be nice for me to look at and compare. And I will take names from age and gender. If you can see, age and gender now became columns, and the values are the drug use. The separator is the comma. So here's the separator. And this is how our new table looks like. So I have the year, I have the ADC code, I have the drug, and I have the age categories and the gender categories here. And now it's much easier to compare the use between women and men in each of the gender, in each of the age categories. So that's great. Now I can numerically assess what's the difference between each of those. So this is super nice, but again, this is just a table. So this is something that looks nice as an output in our markdown format. But for instance, I want to have it as a table. So, and then I have something for that as well. The package that is called GT. Before I do that, I also noticed that my ADC codes are in different places because the data set is sorted by year. And I actually want it to be sorted by year, but also by ADC code. So the same ADC code is next to each other. So this is better. Now I can compare the last 2 years and the same. You can already nicely see and compare. That's great. So now remembering that we have the GT package that will produce a nice document that you can save in Word format. So I will use GT package function GT. I will run it and it will output this nice table that I can save in docx format. And you can say that it is nicely formatted. It is ready to be read by people. I have all the information. I have all the labels. They're in nice shape and form. I can nicely compare the numbers. So this is something that is ready for a report. Maybe I just want to add one last thing. And this is, again, using the GT package. I think that the information about what this table is about is missing. So I want to have a nice header. And also I want to give an explanation of what these numbers are. So I will add again a couple of lines from the GT table, and the function is called tab_header. What I will say is that the title of this table is the use of antibacterials for systemic use in certain age groups that are potentially vulnerable, right? The children and the elderly. And this is the information that is presented by sex as well. And this is Denmark, and I only present the last 2 years because maybe they're most important for some decision making, or maybe they're important for developing a research question that I will answer later using more data or a different kind of data, for example, data on individual level. So this is it. And then I will use the subtitle that will tell people who are seeing this table that these numbers are the drug use or drug use rate that is computed per 1,000 people in the underlying population. So the underlying population is exactly women here between 0 and 19 or 0 and 18. And the population, underlying population here are men or boys under 19 and so on. So that the underlying population is clear. And I will run it again. And here I have the nice title and I have the nice subtitle as well. And I could save that as a document. And this is a nice summary that has both information and table that is easily interpretable and also nice set of plots. So yeah, this was an example of how I sometimes or rather often work with openly available data to do such reports, to check the data that I work in that is on individual level, whether or not aggregations are looking correct or not, using the data that is publicly available for research. So it's really nice. Yeah, this is the practical case that I had for you. I think I'm a bit later maybe than I promised, but I will be glad to take any questions that you have.
Okay, thank you so much, so much. We're grateful for this session. And I think we're getting some comments in the chat.
I will also share the post that summarizes everything that that we've been doing. I can also share. So these are all my code snippets and everything that we've done today. So it has all the same descriptions. It actually has one extra that we didn't do because we didn't have time, and that is after preparing the plots for the trends. We could also do something like that, where we actually look at the distribution of the drug utilization by age category, knowing that the lowest is actually in the recent years. So stuff like that, and everything else is the same. So yeah, this is, I think, the last thing that I could share my screen with. Yeah, if you have any practical questions about packages or the code that we used or anything else, I'll be happy to help.
Okay, thank you so much. We're really appreciative of your time. And I think I noticed so many epidemiologists in the chat, in the participants that are here today. So I acknowledge your presence there. So especially from NCDC. So we're grateful. We're grateful for your presence here. So I believe they've taken so many knowledge from the session, and they can see the practicality of using R in their daily work. So if there is any question you want to ask, a question, or you have a comment, you're free to go ahead.
You can also contact me through my website or through LinkedIn if you have something coming up later on. It's completely cool. Can do that. We'll be glad to help or to discuss something. And thank you so much for inviting me. It was a really, really fun session.
Thank you so much. I think I'll share your link with them now, where they can get more information and contact you. So I'll put that in the chat box.
Oh, I think Blessing has a question. Please go ahead.
Hi, Elena. Hello, everyone. Good morning.
Hi.
So that was an awesome section. That was an awesome section. Sorry.
Thanks.
So I don't really have a practical question to ask, but then I'm a research assistant, and I really want to go into public health epidemiology. So I am a beginner in R. I want to know if there are like internship opportunities where I could, build a career in this. And if you have any resource, if you have resources to share that can help a beginner in R, I would really appreciate that.
Yeah, that's an awesome question. I actually know that our studio has some scholarships, but I don't know if they still have any more, to be honest. But I think that there are so many open source things to look through, and videos, and especially everything that is being shared like through our studio. And I don't know if you're on Twitter. There are so many people on Twitter who are posting like amazing tips to learn from. And also what I could suggest is that just learning by doing. This is for my case. You just say to yourself that there is a nice project that you want to do, and it requires some software usage, and you just go with R, and you Google every 5 seconds, and it gets super annoying. But in the end, this is how you learn. The Stack Overflow website, I think everyone knows that, where people ask all kinds of questions, and oftentimes they also get super nice answers. I think this is one of the most used resources for right questions that come up. But yeah, I can maybe drop a couple of links in the chat of the things that have helped me when I started. And like our studio blog, I think it's a really nice resource. I don't know, maybe someone else who recently started has something to add, because actually what I noticed is that the the newcomers know more than the people who already have been doing that for some time, because the new things come up all the time. So it's actually kind of nice to be together with someone learning something. That actually reminded me that there is a Slack channel for the book called Art for Data Science. So this is for sure a thing. This is for sure the thing that you should look into for learning. I will share this link. I think it's an excellent book for a starter, and it was renewed recently. I think I just dropped the link for the book, and there is a Slack channel for this book, the R for Data Science. I don't know if I can send the link for the Slack channel, but I think maybe I can. Just let me get in. And the people kind of reading the book together. I think our ladies are also present. Also, like, ask questions of things. It's kind of really nice to stay in touch with the wider community of people. So the Slack channel is called R4DS. I don't know. I think my internet is a bit slow or something, doesn't load. And probably that's because I have this huge R session, which I will now close. Okay, let me see if I can share this channel somehow. Okay, I will share the screen, so maybe that would help. Or maybe not. Just a sec. Okay, yeah, I think I found this is I think you can maybe invite yourself in. I don't remember how I got in, but I think it is open. Birgit, do you know if this R for Data Science channel is somewhere you can invite yourself?
You said?
Do you know if this R for Data Science Slack channel, if you can invite yourself there? Or if you should invite?
No, I'm not sure. Okay,
Yeah.
I think maybe she can try that and try to join. It's by request, I think.
Yeah, I think so as well. Yeah, so yeah. You try that. If it's not working, contact me through the website and we'll figure it out. Yeah, it should be hard. Yeah, these are I think the tips from the top of my head for starting with R.
Okay.
Yeah, that someone else wants to ask something.
Okay. Thank you, Blessing. Okay, do you have any comments, questions? Okay, I would like to add with what Elena has already given. So she has shared some very, very important resources with you. So you can check out on all the resources there. Then you can also follow us on LinkedIn and chat with us. So we can also give you more tips and where you can get resources to build your career in public health. So that is what I would just say for now. So that I'll also maybe directly share with you, Blessing, our WhatsApp group, because for some security reasons, some people just join our WhatsApp group anyhow. So I'll share directly with you now in the chat box. So you can join the WhatsApp group, then we can continue the discussion from there. Okay, so if we have any other question here. So do we have any question? Okay, I've shared the link with you on the chat, Blessing, so you can get in touch with me through the chat, the WhatsApp group. Then also, if you contact us on the LinkedIn, I would be available to answer your questions, then kind of direct you, you can link up with us. This way you can learn so much. And also on the meetup, join the webinars, then you can really gain a lot. So you don't learn in isolation, you learn in group. So you'll be able to get more resources and helpful and links for you to grow. So thank you, everybody. I'm really grateful for your presence here. Then I would like to really specially thank Elena. So it's really wonderful to have you here. And I think the awesome tips and the practicality of what you've done so far is a boost to encourage those who are trying to look at it, going to the public sector, epidemiology, and so on. So thank you so much. We really appreciate you, and we're wishing you all the best. We look forward to having so much to do with you in future. Thank you so much. And on behalf of the Our Ladies Abuja, I'm so grateful. We're saying a big thank you. Thank you.
No problem. It was all fun for me as well. Thanks for the invitation, and have a great weekend now.
And you too. Thank you so much. So it's bye-bye from me now. So thank you, everybody. So see you some other time.